Hi, today we're going to do number 572, subtree of another tree. So in this problem, we're giving two trees, and we want to return true or false or not if this second tree, the subroot tree, is an actual subroot tree of the first tree. So here we see in this example 3, 4, 5, 1, 2. The subtree is 4, 1, 2, and it is a subtree because this 4, 1, 2 matches it up, so we return true. However, in this one, 4, 1, 2 here, 4, 1, 2, and this one has another leaf of 0, so we return false. So how can we solve this problem? So one way is to check we will iterate through root and then check if that node is equal to the subroot. So this will be using DFS, since we'll go one by one down it, recursive way to do this. And then iterate through the node. And so we'll go get this 3. Is this 3 the same as the subroot? No, it isn't. Then 4. So is 4 same? Yes. So we keep going. 1 is the same as 1. And then 2 is the same as 2. So we return true. By doing it this way, the time complexity is going to be O of n times m. So because we're going to have to iterate through root with this n, and then for each one, we can check the subroot, which is m. The space complexity will be O of h1 plus h2. So h1 will be the height of the first tree, h2 will be the height of the second tree. So when we do a recursive call stack, it will be the longest branch, and that will add up to it. So that's one way we can do it. How else can we do it? And another clever way we can go about doing this is to serialize the trees, which means we convert them to strings. And then once we convert to strings, return if the root includes the subtree. And with this way, the time complexity is only going to be O of n plus m, since we're iterating through each tree to create the serialized form. So that loop will be O of n and m for the subroot. Using includes in JavaScript, the pre-built function method will be O of n plus m. The space complexity is going to be O of n plus m as well, because we're creating a new string for each tree, and it's going to be as long as the length of the tree. And since the serialized way has a better time complexity, although it has a slower space complexity, we'll go with this way. So first we can create a helper function to serialize, and we're taking a node and an array, and we're going to use array first to push everything into an array, and at the end of it we convert it into a string, because strings are immutable, so we use arrays to be more efficient. So if node doesn't exist, we push. What do we push? We need to keep track if it's null or not, so we can use a symbol like a hashtag. Sorry, we don't return, we are dot push that in there, and we can return out of it. Otherwise, we want to push the value. So our dot push the node value, And we also want to add a delimiter to keep track to help separate the values out, because if there's like a 12 and a 1 and 2, that could be a problem. And here we want to recursively call the rest of it, serialize node.left, and pass in the same array, and then serialize node.right, pass in the same array. Great. So now we have this. So we can call it. So first we're going to need the array for each one. So const root array. And then we do const, and then we call the function serialize root and pass in the array. And now we do the same for the subroot. So sub array and serialize subroot and sub array. And now we convert it to strings. So we do const root string equals root r dot join, and we can just add a comma there to help keep track. Const substring equals sub r dot join as well. And now we check if it's within it. Just return root string that includes substring. Great, so that's the serialized way, and let's do it the other way. So here we can create a helper function to see if it's the same tree. Is same tree, and we do P and Q for each of them. And then if both of them are null, we reach the bottom of the recursive call for this, return true. Now we return our false conditions. So if one of them is null, false, and then return false if the values are not the same. And now we recursively call this. So return is same tree p dot left, q dot left, and we have to make sure it's both of them are true. So we do and is same tree p dot right, q dot right. And now we need our DFS function, takes in a node, and this is what we're going to return at the end, passing a root. So if this new root is null, we return false, it's not the same. And then we know we made it through the bottom, and it's not the same as what we have in the subtree. And now here's when we're going to call this function. So it's if is same tree for the node and sub root, return true. And now we have to recursively call this, so return DFS node dot left, where one of them makes it, only one of them has to be true, node dot right. Great, so those are two ways we can solve this problem. One way is to use DFS, where we iterate through the root, and then for each one, we check if it's the same tree, and then recursively call that to find out, or we serialize it or convert it into a string where the key is for each null one, we want to create a hashtag and add a comma between each values to divide like double-digit numbers versus the same. And once we convert it to strings, we just compare it if the subroot is included in the root. And that's all. Thank you.